Thank you, the organizing committee of National Institute of Technology, Pondicherry, for giving this opportunity to deliver a session talk on recent trends in welding robots during this faculty development program on industrial robots for future factories. So I'm starting with the brief introduction, and then I'm going in deep what are the recent trends and how the welding robots that are being used in industry in order to enhance the productivity of industry. So let's define a robot, which is a reprogrammable one and multifunctional device, which is used for various functionalities such as to move materials, parts, tools, and specialized devices through programmed motions. So the definition, how this is different from a machine, because a machine can also do such activities, what I emphasized, but there is a small difference between a machine and a robot. The differentiation of a robot from a machine is the machine should qualify certain characteristics or features that a machine can be said as a robot. What are those characteristics? The first characteristic is sensing and perception. The device will sense the environment, not only the sensed environment, but also it should perceive what is the useful data from the sensor data. Then a machine should carry out different tasks. Okay, so the tasks may be manipulation or maybe sort of assembly operation, welding operation, painting operation, or machining operation, and it should be reprogrammable. So the reprogrammable one means the device which is controlled through certain computers should be programmed again and again. It means that it is not just simple like a fixed automation. Okay. So whenever we change the program, the machine functionality should change with respect to the commands that are being used by the users. Then the most important property of a robot is autonomous. So autonomous, it is nothing but without the intervention of human. So it should take the decision by itself according to the environmental change. For suppose if a sort of uncertainty presents, how human responds? What is the activity by the human with respect to his intelligence? That intelligence should be applied by a robot. So if a machine which has these characteristics, then we can say the machine is a robot. Now, the robot, why it is very important? Because day-to-day life, most of the industries that are acquainted with interdisciplinary subjects, not only a single mechanical engineer can do all the activities, but the concurrent or the integration of certain branches will leads to the product enhancement as well as its productivity. So a robot, it is an interdisciplinary or mechatronic system which involves the branches of mechanical engineering, electrical engineering, electronic engineering, and the other so many disciplines. So if we see the architecture of a robotic system, initially the main role in the robotic system is of a mechanical engineering. What a mechanical engineering do in robotics? Because any mechanism, robot is a kind of a machine, so it will have some mechanism. If there is a mechanism, there should be some motion analysis. This is called kinematics, in which the involvement of analysis on displacement, velocity, and acceleration. Okay, so the mechanical structure should have some strength, right, and to move the mechanical elements from one position to another position, or relative motion between some elements of the structure, then there should be certain amount of force or torque is required with the aid of power. So this is the duty of a mechanical engineering in terms of a robotic specialization. So once the mechanical engineer decides the motion and the dynamics of the mechanical structure, then electrical engineer coming to the picture, how much is the power, and for which to attain that much power, what type of actuators should be used. Once the mechanical actuator is ready to move the elements of a robotic device or the mechanical structure of a robot, then the next part is to control the motion. The control the motion is with the aid of communication. So there is communication between the robot and the human, that is through certain sensors or certain communication devices. Apart from that, now the mechanical system is ready and it is able to control the mechanical structure of the robot. Now the point is that the mechanical structure which is controllable should act as expert knowledge. It means that the decision planner should be intelligent one. So whatever the decision it is taking, the robot is taking, that should be the final decision and should be the optimal decision. So in order to achieve that, the computer's technology will be used, like integration of artificial intelligence system, machine learning, so that now the complete body is ready that the robot can do the autonomous work. So the integration of these branches gives us the robotics field. Okay. Now, the same structure only, if you see how it acts, certain environment is there. It may be the environment for assembly, it may be the environment for welding, it may be the environment for painting, whatever it may be. Now, in order to do certain work in such environment, what is the architecture of a robot? So initially, the environment should be planned. Okay. Once the environment is planned, in order to acquire that environment, what type of sensors that are being used, it will be decided. So from the sensors, it acquires the environmental data, and the acquired environmental data should be perceived what is the useful data from the sensor data. Once the robot perceived the data, then it plans what is my position and what is the environment position. That is called localization. So now the robot know its position in the environment through the localization. Thereby, it go for cognition or planning. Now I know my position, so where I should go. That is like planning, for which the robot should be with a suitable motion planner. It may be artificial intelligence based, or it may be some geometric based, or it may be through certain intelligence technology. So once the motion control is done, then this motion control will be interfaced to the controller of the robot. Okay, so through the robot controller, the actuators which are joined to the mechanical elements of the links will be controlled. So the mechanical structure thereby controlled with the aid of the robot controller. If there are any errors, or if there are any certain disturbances during the operation, then the information will be given back to the controller, so that those will be rectified with the aid of certain sensors. So here, the best example of a robot is given. The robot is sensing the environment. It is just like an example what we conducted, what we did in NIT Rourkela of Automation Lab in Department of Mechanical Engineering. So the robot is now moving while avoiding certain objects and going towards its target. So there is involvement of mechanical, because the wheel geometry, wheel locomotion, everything will be identified here. Okay. Then computers technology, it is given some artificial intelligence applied to the robot to move in the environment. Okay. And there is the use of sensors, electronic role of electronics engineering. Okay. So now the complete system, it is multidisciplinary, and it is operation in the environment. But the point is this: why do we use robots? Not only for other applications, of course, not only for the welding applications, for the other applications also. So generally a robot that is used in 4D environments to perform 4A tasks. What are these 4D environments? It is like dangerous environment, dirty environment, dull environment, and difficult environment. These environments to perform 4A varieties of tasks, that is automation, augmentation, assistance, and autonomous. So a robot can do automation tasks. A robot can be used for increase the productivity. A robot can be used for assistance of the user. A robot can do the tasks autonomously. So this welding robot, if we see, welding operation is difficult operation because it involves the skilled labor to perform the welding operation. Okay. So this welding is difficult environment, one thing. Second thing is that this difficult job is to be automated, and it is to be increase the production rate. So for automation tasks and for augmentation tasks in the difficult environments, we introduce welding robots. So these robots, particularly industrial robots, are being used in the old world. 70% of the robots that are for welding and painting applications, and 20% of the robots are for pick and place applications, and 10% of the robots for some other applications. So these robots generally are categorized into two types. One is robot manipulator, okay, fixed robots and mobile robots. The fixed robots, the work environment is fixed, and within that work environment, the operations will be performed. Whereas the mobile robots, there is the environment, it is not fixed, flexible environment. It can move around the manufacturing plants to do certain tasks as per the user needs. So these robots are classified, I mean to say, the motion of the robots will be given as per its locomotion technology. So what is the locomotion technology is suited for the robot? Initially, the designer should know. There are varieties of locomotion technologies that are being introduced. Okay, there may be aerial robots, there may be wheeled robots, there may be legged robots, there may be the locomotion such as humanoids, underwater robots. So among these various locomotions, what is the need of the locomotion for the welding? Okay, what type of locomotion we should choose for performing the welding operation? So here, if we see, there are a number of robots as I emphasized. Okay, if we see the locomotion of each of the robot, so initially a humanoid is there. How it moves? So this is the movement of a humanoid, okay, which mimics the human behavior. Okay, and if you see a legged robot, so the legged robot it is developed by Boston Dynamics. The legged robot will be used generally for the movement or transportation in terrain environments. Okay, so it can the balance of the robot is quite good, so that it can move anywhere, even in terrain environments. Here another locomotion is a jumping locomotion. The jumping locomotion is how it is, right? It can sense the environment, how much height it has to climb. Okay, once it is sensed, then it can jump to that much height. Okay. So this is a jumping locomotion. Now, another locomotion is microbot. So if the structure is in micro level, okay, if we see the MEMS, micro electromechanical elements, okay, so through which the robots can also be developed. So this is the Epson, one of the famous organization which is developed a microbot, okay, so which can fly in the environment. Okay. This is aerial locomotion. And another locomotion is sliding. Okay, so for the military applications or defense applications, okay, the sliding robot that are being used, once the environment it is sensed, the robot starts sliding over the environment. Okay, now the robot is starts sliding once it is detected its environment. Okay. Sorry for the interruption. My videos are visible to you or not? I am playing some videos. Okay. So along these, there are varieties of locomotions that are being developed and presented. Okay. So among these locomotions.
Excuse me, sir.
Among these locomotions, manipulator are nothing but the fixed robots is called industrial robots. Okay, these industrial robots that are suitable for performing the welding operations. So let us see the anatomy of an industrial robot, which consists of rigid bodies connected by joints. This is simply called as links. Okay, and these links are connected with joints. Okay, so these joints may be the actuators. Okay, those actuators either may be electric or hydraulic or pneumatic. Okay, once the mechanical structure is ready or the mechanical elements are joined together, then the most important aspect is the tool. What is the tool? Is to be mounted to the mechanical structure or the manipulator. The tool is nothing but it may be a welding torch for performing welding operation. It may be a painting gun for doing the painting operation. It may be a grinding tool for machining operation. So these industrial robots or the manipulators are characterized in various ways according to its configuration. The configuration, it is maybe of Cartesian configuration. It is nothing but it consists of prismatic joint. Okay, and cylindrical configuration, I mean to say that the workspace of this robot configuration is a cylinder, and a spherical which consists of RRP joints, revolute and prismatic joints. Okay, and articulated one. In this articulated one, all the robot joints are the revolutionary. Okay, so the workspace of this articulated robot, which is a hemispherical structure. Then the next robot configuration is SCARA robot. SCARA robot, generally these SCARA robots that are used for assembly operation. The name itself, SCARA, Selective Components Assembly Robotic Arm. Basically, this SCARA robot, which has 2 degrees of, I mean to say, 3 axes or 3 degrees of freedom. Of course, some advanced robots of SCARA, which have 4 axes also. So which have one revolution joint, another revolution joint, and another prismatic joint. Okay, so to these configurations, robot configurations, one end effector will be attached. That is called wrist assembly structure. Okay, to this wrist assembly structure, the end effector will be attached, as emphasized previously. So, why these robots and how these robots being used in the industry? For suppose if we see the manual operation, okay, and hard automation are like fixed automation and robotics automation, automation with the robots. Okay, if we see for small and medium production volumes, robotic production yields the best cost per unit performance, right, when compared to manual and the hard automations. So the robots are being used for medium to large scale, not for the small scale, of course, but for medium to large scale production, these robots are being used. We can say this is like a flexible autonomous automation systems. So the robot configurations for the industry purpose, just like how our hands, our arms, we are doing the tasks with the aid of our hands. The same way, these robots are also designed. For suppose, just consider a human hand which has 6 degrees of freedom. Okay, so those are like base rotation, the first one. Okay, shoulder rotation, okay, elbow rotation, and wrist pitch and wrist roll. Okay, so these motions are these degrees of freedoms that are incorporated to an industrial robot in order to mimic the behavior of human hands. So these 6 degrees of freedom robots that can be directly integrated to robot, so that these robots can do the tasks what a human hand can do. Generally, we do the tasks in the industry with our hands. So instead of our hands, these robots, they do the tasks according to the program or commands that are given by the users. Coming to the concept of this robot, okay. So most of these manufacturing industries that are acquainted towards the robotics for automatic, adaptable, and intelligent operations, particularly for welding operations. This robotic welding, it is for favorable circumstances, for example, which enhance the efficiency. Okay, and it produces the quality welded joints. And the robots, as described earlier, we can go for the adaptability, good adaptability in the workspace. These welding robots, basically it is teach and playback mode. First of all, initially we teach, then it follows the user guide. Okay, so they have no enough adaptability. Earlier they are being used, this teach and playback robots. But point is that this teach and playback mode robots, especially for welding operation, it is not successful because welding requires automatic control. Okay, and whenever they use this teach and playback modes, there are several errors that are arising during the welding operations. For suppose if we teach the robot once and do the welding operation, for one time it is okay, for 2 times it is okay. If there is some change in the weld geometry, if there is change in the error in the weld position or orientation, then this teach and playback mode of procedure will not hold good to perform the welding operation. So there are various varieties of welding operation that will be discussed later. Now let us see the advantages of welding operation with the aid of robots. Why we use robotic welding instead of manual welding? One is that the first advantage is the robotic welding can be very useful in terms of both cost and quality for small and medium production volumes, right? Second advantage is it consistency in performance by maintaining the quality for a long time. So same quality of the welded joints we can produce for long runs. It may be for 1,000 times or 10,000 times or even for a lakh of runs. We can maintain the same quality throughout the welding operations. It makes the process quite flexible and also can be utilized for other modern manufacturing processes as usual. So this welding robot, what is the structure of a welding robot and what are the various infrastructure that we have to acquire to perform the welding with the support of robots, let's say. So as we know, a robot is nothing, an operation it is performing by a robot needs a controller, that is a robot controller. Okay, so to this robot controller we have to give certain inputs and it will give certain outputs. So as we know, the output of the welding robot is nothing but welded joints. Okay, na? And through this controller the robot has to move in the desired path. Okay, so the output would be one robot motion. The second one is the motion control or optional positioner or work motion and its control. Okay, so these are the outputs for a welding robot controller. Okay, and the input we should give, one is to interface with the welding source. Okay, and interface with the electrode feeder and its control. So whenever we give the inputs, this welding inputs, okay, to the robot controller and the inputs towards the robot, okay, then it controls the motion of the all the robotic joints or the elements of the robot, elements of the robot or links of the robot while doing the operation of the welding. So this welding robotic systems, it is of various phases. It has three phases. The first phase is preparation phase. Okay. The second phase is welding phase, and the third phase is analysis phase. Okay. So this preparation phase is nothing but the pre-welding operation. Okay. And second one is the welding operation, during welding operation, and the third phase is the post-welding operation. So prior to the welding operation, the robot should understand the user commands. Okay, so proper calibration to the robot will be given. Okay, if we equip certain sensors to the robot, okay, and what is the sensor calibration, what is the robot calibration, maybe it's what is its home position, how do we synchronize the sensor with the robot motion. Okay, so such calibrations will be done in the pre-welding operation. So like computer aided structures or computer aided manufacturing modules that can be used in pre-welding operation or the preparation operations. So initially we can design our welding structures and we can plan our welding operation in the virtual mode. Okay, so from the virtual mode we get we can confirm the welding suits and the welding can be adequate to perform the operation. Okay, then we can feed it to the robotic device. Okay, thereby the welding will be processed. Okay, so the robot program might only need minor tuning for calibration, which can be easily done by the weld operator performing selected online simulation of the process. So this is a pre-welding operation. This is like a preparation mode. Okay. Once the preparation mode, I mean to say that now the sensor is ready, welding source is ready, robot is ready, then we have to do the welding operation. So this welding operation, during this welding operation, there are certain things that are to be incorporated. Okay, so those are like seam tracking. Okay, seam tracking is nothing but what? When two weld plates are joined together. Okay, so the weld seam, how the welding is to be performed, and what is the trajectory that is to be followed by the weld torch. Okay, these are to be identified, and changing weld parameters in real time. Okay, which emulate the adaptive behavior of manual welders also. So during the welding operations, it is necessary for the robot to analyze these parameters. Okay, whether if there is some change in the weld plate geometry, if there is some misalignment, then initially during the simple, it will identify and it gives the data to the user, so that which will I mean to say the user will correct the alignment, and thereby the welding operation will be processed. Okay, so now the welding operation is also being done. Okay? Then the next phase is to analyze the weldments for its quality. Okay, so the quality like as destructive type or non-destructive type tests, certain tests can be performed on the welded joints, so that the quality will be analyzed. Thereby we can reprogram the robot, we can reconfigure the robot or recalibrate the sensors in order to achieve the desired weld quality after this inspection. Okay, so after seeing these three phases, what exact automated robotic welding that it gives? The first one is of utilization of sensors. So what are the various sensors that can be integrated to the robot, or which sensors that are used to acquire the environment, especially weld environment. Welding environment means to detect the weld objects, to detect the joint parameters, to detect the misalignment of the welded plates. So what are the various types of sensors, and how do we utilize these sensors? Initially we have to identify. Once we identify the sensors, then the next is identify the joint parameters and weld process parameters. Okay, so in order to find these joint parameters and the weld process parameters with the aid of some sensors, these two will be synchronized in order to control the motion of the robot. Okay, so now the motion of the robot is controlled in order to, I mean to say, the motion of the control, the motion, robot motion is nothing but here the motion of the torch, weld torch, which is equipped to the robot as end effector. So which will be controlled, okay, according to the information that is acquired from the sensors. Okay, so on combination of these sensors is synchronization to the robot motion, which gives the automated robotic welding, right? So this robot programming for the welding operation, it may be done in three ways. Okay, so the programming is like manual methods, or it may be online programming methods, or it may be offline programming methods. In the manual methods, what happens? There is no requirement of sensors or any sort of software or hardware. Okay, the human, it controls the operation. Okay, and there is like this use of manual manual programming method requires no special hardware or software on site other than that which is used for the manufacturing process. The second one is that, especially for the robots, online programming. In this online programming, there are two varieties in the online programming, which may be lead through or which may be walk through. For suppose, if we consider this walkthrough method, the operator moves the torch manually through the desired sequence of movements, which are recorded into the memory of playback during the welding. The walkthrough method was adapted in a few early welding robots, but did not gain widespread use. Of course, because this walkthrough, it is initially the user detects the movement of the robot, and then which will be recorded, and then it is given to the robot. So the conventional method for programming welding robots is online programming with the help of a teach pedant. Later, this walkthrough, then lead through will be has introduced, and this lead through programming which uses one teach pedant. Okay, so through this teach pedant, the user can control the robot so that the desired position and sequence of motions that are recorded. Okay, and the robot will continue the same operation for long time. Okay, so that is like a teach pedant or lead through programming. So this lead through or walk through, of course, most of the laboratory models that are through online programming, but there is a disadvantage with online teaching method, that is the programming of the robot causes breaks in production during the programming phase. So the third category of robotic programming is offline programming. So in this offline programming is initially we don't know the robot structure. Okay, I mean to say we do not deal. Need not to deal with the robot. Okay, physically. Whatever the analysis the robot has to do, initially we do those the analysis in virtual environment. Okay, so for which we use CAD softwares. Okay, the workpieces will be designed, the robot will be designed, the features will be designed, and every work cells are designed in the computer-aided design software. There only we will obtain the trajectory of the weld seam. Okay, and the motions of the robot. Okay. So now, once the weld seam is identified, robot trajectory is identified after performing certain analysis, then this will be stored as a program. Okay, the trajectory to be followed by the robot along the weld seam. Okay, now this program will be fed to the robot. Okay, so whatever the analysis it is to be done, that complete analysis will be done in offline. Okay, without any physical presence of the robotic devices. Now the results that are obtained in offline programming or in virtual mode, it will be fed to the robot, so that the robot will do the operation according to the program what is analyzed during in the virtual. So this robot programming, I mean to say offline and online. Online mode is very convenient. However, it is also has some drawbacks. If we see the robotic programming for an intelligent robot, so it is very difficult and even impossible to anticipate and identify all situations that the robot could do during his task execution. That is quite a fact. Therefore, the software developer must specify the categories of the situation, what are the various uncertainties the robot may face. For suppose in the environment, the welding environment, Well, during the welding operation, there may be the chance of misalignment, okay, na? Or there is a chance of some electrode deposition rate, more or less, okay. So these uncertainties initially should be taken care, okay. Thereby, the robot will be programmed what are the various uncertainties and how to avoid those uncertainties with the aid of robot that will be identified. So in the robotic welding, there are various problems. Those problems are, one is consistency. So throughout the weld operations, the same consistency should be performed. Okay. So and the time and effort taken to program the robot to weld a new part can be quite high. For suppose if it is a large amount of production rate, that is fine. But it is one product, two products, it is very quite high because the robot, it is costing in lakhs, and the complete environment, the programmer, everything will be very high. So the initial cost is high. However, the quality we can get more. And next problem in robotic welding is it requires skilled welders. Okay. So to operate the robot and to understand the welding robot and to understand the synchronization of these sensors with the robot, it is quite a difficult task. But so this is one of the drawback that we can say. And also robotic welding cannot be implemented in all the environments. For suppose if there is like pressure vessels, interior tanks and shipbuildings, it is very difficult for the robotic welding to implement in those areas. Apart from this, the sensors need in the robotic welding. Okay. So, as I described, teach pendant mode is one of the way that the robot can be controlled. But how do we sense the weld parameters, the robot parameters? Okay, and once the sensing of these parameters are done and the robot welding is performed, how do we rectify or how do we ratify the quality of weldments? So these are the very important parameters, and for these parameters like sensor parameters, we have to use certain sensors for robotic welding operations. Okay, initial robotic welding sensor, it is for seam finding. Seam finding is nothing but what? If two plates are joined, okay, are to be joined. So what is the gap, and what is the length, what is the width, what is the thickness of the weldment? It is very essential to know. So this is called seam finding. Okay, and seam finding is done by adjusting the robotic manipulator and weld torch to the right position and orientation in relation to the welding groove. Okay, prior to the welding operation. So this seam finding and tracking, it is developed in 3 generations: the first generation, second generation, and third generation. First generation is the way of traditional obtain of seam tracking, okay, in which 2-pass welding system is available. Okay, in the first part, I mean, the obtained seam in the first pass will be used for the seam track in the second pass. It is followed to the first pass. Okay, so thereby the seam will be tracked. Whereas in the second generation, seam tracking in real time. Okay, so that is obtain of seam geometry and welding in 1 pass. Okay, so it does not require 2 pass. Even in a single pass, what is the seam geometry? Okay, and what is the trajectory of the weldment? It will be up. In the third generation, seam tracking in real time with obtaining information about variations in weld shape. Okay, so sometimes the weldments which have like complex geometry and uneven geometrical structure. Okay, so that variations in weld seam also can be obtained during this third generation of welds. Okay, so generally this robotic welding, it is done for various welding operations like gas welding, tungsten welding, laser welding, various welding operations that can be do with the aid of robots. But the sensors that are used for seam tracking will be of two categories. One is contact type category and non-contact type category. So contact is nothing but it is touched to the weld plate so that it can identify the seam. Non-contact type, in non-contact type, it won't touch the weld plate, but it can identify the weld seam track through the aid of some sonar based or through some aid of magnetic effect or light effect likewise. Okay, so if we see this tactile and non-tactile sensors, according to the performed survey, past researchers, most of the past researchers, they use laser vision sensors, okay, for seam tracking purpose, because laser vision sensor, if you see the error rate, I mean to say, this is minimum error rate and the red color, it is showing the maximum error rate. So for the laser vision sensor, the error rate is quite low as compared to the other sensors. So here, most of the previous researchers that are worked for laser vision sensor. Next to laser vision sensor, only vision sensor through image processing, which is used. And also coming to the, if you see the figure 9, vision sensor will obtain less accurate, I mean to say, the error as compared to the, I mean to say, next to laser vision sensor. So these vision sensors and laser vision sensors are, I mean to say, most advanced technologies in the welding robotic systems to find the seam tracking. Once the seam tracking is done, then only the welding robot can perform the welding operation uniformly to produce the uniform and smooth welded joints. So the way of seam tracking with the vision sensor is slide. For suppose this is a robot, okay, and this is the laser and vision which is equipped here, and this is the weld platform where the welding is to be performed. Okay, so this robot is controlled through the commands as well as through the controller, and the weld electrode and its gas supply will also be controlled through this through the robot controller. Okay, so this has a major role in automation of robot welding by acquiring images of the weld seam. Okay, so the captured images of the weld seam will then further processed for performing the welding operation. Okay, so here the seam tracking with vision sensor, how it is tracking the, I mean to say, tracking the seam and how it is identified. Okay, and how it is this is a vision can be utilized to recognize the position of weldments for the proper arrangement of parts related to the welding operation. So if you see here, this is the weldment positions through the vision sensor. It is a 2D vision sensor. So the seam tracking process, initially it involves the calibration of vision sensor. Okay, then the weld operation will be started. Then once the weld operation is started, then it takes the images during the welding operation. These images, once the image is acquired, then it is processed. Okay, and it checks the images for any toss deviation or misalignment of the plates, and then the correctness or the refinement of the algorithm will be done. Okay, this refinement of the algorithm will be given to the robot controller. Then the welding operation can be performed. Okay, so in the image acquisition, so if we consider an image, okay, so this is the image for the two welded plates it is considered, and this is the image that can be acquired through the image technology. Okay, so there is a few flow chart that for the weld seam extraction. Okay, initially image it will take from the weldments, and then it will eliminate the background. Then it adjusts the threshold. Okay, then it will detect the edges of the weld plate, and then it takes the seam, weld seam, and it gives the final weld seam to the user. So there are various image processing techniques that are being utilized, and various ways the weld seam are identified. First of all, the most widely used technology is fuzzy based weld seam technology. Okay, through which the user can identify the weld gap and the midpoint also of the weld seam. So this is the work done in NI Vision Assistant. Okay, so once the image is acquired, it gives the weld gap, okay, and its thickness, and also it gives the middle point, how where is the middle point of the weld seam. So the same way, the seam tracking can also be done with laser sensor technology. In the laser sensor technology, how it works, there are two plates. This is one, and this is the second plate. This is the workpiece. Okay, so to this workpiece, this is the laser which illuminates laser rays. Okay, and this is the CCD camera that is fixed apart from the laser sensor. Okay, once the laser is focused on the plate, then it will identify the profile of the welded seam path. Okay, so thereby it will identify what is the distance between the two edges, that is joint gap, and it also determine the thickness of the weld plates. Okay, once the joint volume is done, okay, then only the robot can identify, a user can give the rate of feed rate of the electrode. Okay, so once the laser sensor fixed to the robotic device and which moves along with the torch, then it will cover the complete weld volume or weld joint volume of the weldment. Thereby the seam track will be identified. Okay, once the weld seam is identified, then the robot will be programmed. This is the aim of laser sensor with the camera, laser vision camera based seam tracking technology. So in which this method is also same as like the vision based sensor. Calibration, initially it has to do the calibration, laser vision sensor, then auto finding of weld start points, then image acquisition, then for the image acquisition, image processing will be carried out to find out the feature points on the projected laser stripe, and then checking of torch position, deviation, or weld seam position details, then corrective signals by seam tracking algorithm, and once the refinement is done, then it will go to the robot controlling, and the robot will be controlled by performing the welding operation. Then the required the quality welded joints will be obtained. Okay. So here the laser sensor, how it scans the image and how it filters. For suppose initial scanning, it is getting some images like this. It is a noisy profile. So the noisy profile, while eliminating this noisy profile, it will generate the filtered profile as like this. Okay. So once the filter profile is obtained, okay, so then it is identifying, see, for suppose this is the reference point, and it first along the weld plates, the geometry it is obtained here, characteristic point detection. Okay, so while it is obtaining this seam tracks, then the start point and end point will be known, and the featured filtered profile is obtained through the laser sensor technology. Then the trajectory to be followed by the robot is generated here. Okay, thereby the robot can perform the welding operation according to the path generated by the weld seam as like this. This is the path or the seam obtained by the laser, and in this path the robot has to move. Okay, so for example, if you consider a U groove, okay, the obtained image will be as like this through laser vision sensor technology. If it is a V groove, then it obtains the the image extraction will be as like this. In the same way, if it is a square groove, then the coordinate space will be identified as like this, and if it is a lap joint, the coordinate space will be as like this. Okay, so once the seam tracking is done, and now it is ready for the robot to do the welding operation. So this is like the controller design or the sequence of operation in a robot controller. Obtain the position of the robots, and then it get the information of the seam profile, then it compute the trajectory of the robot, then it will perform the welding operations through motion command by the controller, so that it will move, the torch will move along the weld seam. Okay, so in our NIT Rourkela, we have a robot like this is a S-cover robot. Okay, so this S-cover robot, which consists of a laser sensor, and it is a vision sensor, which is okay, and which has weld power source. Here you can see, and this is the robot controller. Okay, so which can do work like teach and pendant mode, as well as we can do the offline welding. Okay, so this welding, robotic welding works as like this. Okay, which has laser sensor. Okay, so through this laser sensor we can identify the weld joint. Okay, if any edges deviation is there, that deviation also we can identify, and we can feed it to the robot controller. Apart from this, a weld torch is there, which is equipped to the robot. Okay, and a camera which is mounted on the weld platform to certain height. Okay, so through this camera we can identify the weldment pictures, and then we can identify the weld seam position and its extraction. Then the same weld seam trajectory will be fed to the robot, and it will be fed to the robot controller. So through the weld seam edge detection and finding, as well as its image capture and its identification, the same will be given to the robot for the motion control of the robot. So this is the complete setup of the robot. Here, as I described, this is the torch, and on this welding torch, the laser sensor will be equipped. Okay, and this robot will be controlled to the robotic controlling system, and this is the teach pendant that the robot also controlled manually through the commands which can fed through this keyboard. Okay, and this is the electrode feed rate stand, and this is the gas hose. These are also can be controlled this robot. So this robot has 6 degrees of freedom, as I am said already, which has the load carrying capacity of 6 kg. Okay, so the range of the robot, I mean to say, since it is a fixed robot, it can do operations in the range which is like in hemispherical work volume. It can do its operations. So here we used one CC camera. Okay, and this CCD with its one frame grabber will be attached, and this is a NI vision processor. Okay, so through this we can analyze the image to obtain the weld seam. Okay, once the weldments are ready, here this is the echo fast point laser sensor. Okay, so with the aid of this sensor and the CCD camera, we can acquire the weld seam geometry, and after seam tracking, the weld will be performed by the robot motion. So once the robot motion is done, see here it is given, this is the first plate and this is the second plate. Okay, so these 2 plates will be kept together. Okay, and this is the laser sensor. Okay, so this laser sensor will give 3 reference points. The first reference point, okay, and how much height it should maintain. Second reference point, what is the edge, and the third reference point, what is the in order to find the depth of the weld gap. Okay, so based on these 3 different points, it will identify what is the middle point of, or what is the thickness of the weld plate, okay, so that the feed rate can be controlled during the operation. So this is how the robot position and the EcoFast laser sensor finding of the detected gap. Okay, so this is first position. I mean, this is first position. Okay, at certain height, and this is the reference robot. Second position is the edge, and the third position to determine the depth, and the fourth position to determine the edge of the weld gap. Okay, once it is done, it will give you the complete joint volume of the weldment where the welding operation is to be performed. Okay, so now once we know the robot controller design and its sensors for seam tracking, then the next parameter is to improve its quality. So improve its quality is nothing but, since it has so many parameters like sensor parameters, weld parameters, as well as robot parameters, all these controlled together. Okay, so then only it can we can get the quality welded joints. So in order to get this quality welded joints, a fuzzy regression approach is being used. Okay, so initially to this fuzzy regression system, certain inputs in terms of weld bead geometry, microstructural properties in terms of micro hardness, as well as heat effector zone, and mechanical properties, yield strength and ultimate strength. Okay, so these parameters will be given as input, and we will calculate the output as the weld quality with some index that is called weld quality complex index. Okay, so this normalized input welding process parameters data through which we can obtain the WQ weld quality index. Okay, and then we can relate this input to the output, okay, through this fuzzy regression approach. Once after doing certain number of experiments, like some 100 number or 150 number of experiments, we get various input parameters as well as we obtain various output parameters. Okay, and then these will be relate to the relate in order to get the uptime between the among these process parameters, sensors parameters with the weld quality index. Okay, so here the weld bead geometry will be identified as like this: weld bead width and weld bead height and depth of penetration and depth of bead. Okay, so it will be identified with the microscope. Okay, so then the next role is that once number of input parameters are given, then it will create some number of fuzzy rules, thousand number of fuzzy rules. Okay, so based on these fuzzy rules, then the quality index will be identified. Okay, so this is the number of inputs how we are getting, and number of some outputs in terms of fuzzy membership, how it is obtained, and this is the program that is run for the fuzzy toolbox of MATLAB. Okay, so for the number of design of experiments. Okay, so once we done the number of experiments, we implemented the algorithm in fuzzy regression, then we obtained the relation. Now the point is that once the relation is obtained, so this is the 6 input parameters and output as weld quality index. Okay, so these weld quality index is to be to be optimized. Now we got the relation, one relation, it is with us. Okay, maybe you can consider this is an objective function. Weld quality is an objective function. Now this quality objective function is to be optimized, right? Okay, so how do we optimize this weld quality one algorithm? So we know the objective function. On applying certain boundary conditions or constraints to the objective functions, then we can optimize the objective function. So here the weld quality index, it is optimized in the same way with some algorithm, that is some through artificial intelligence algorithm. Okay, that is called teaching learning based algorithm. Then through this optimization algorithm, we got some data here. Okay, the 6 parameters are to be at these positions or at these values, the weld quality index will be more effective. Okay, so this way, and for the obtained quality welded joint, then stress strain it is shown in this. Okay, and its microstructural image also it is shown how the weld bead it is produced, and for the quality welded joint and the specified parameters. Okay. So this is how the robotic welding operation it is performed through laser sensor technology. So just I'd like to summarize that what is a robot and how the robots are being used for welding operations. Okay, then what are the various sensors that are being used for welding operations? There are so many sensors that are being used for welding, like contact type and non-contact type, and among which non-contact type are the most predominant and effective sensors. Even in non-contact type sensors, laser-based sensors and laser vision-based sensors that are quite quality in producing the weld seam tracking. And once the weld seam tracking it is obtained, the next duty is to control the robot design, robot controller design. So this robot controller design, which enhances the quality parameters not only in terms of welding process parameters as well as with sensor parameters. Okay, the synchronization of these sensor parameters and robot parameters will then be given to the robot controller. Thereby, the robot will be controlled through some motion planning technology. Okay, so from which the sensor parameters and weld process parameters, sensors parameters, once the relation is obtained through some fuzzy regression system, then some optimization technique is to be implemented in order to optimize the obtained relation. So for which we used some artificial intelligence technique called teaching learning based algorithm, from which we obtain the best WQC weld quality index parameters with at which the parameters are varied for. Okay. Thank you very much for giving this opportunity. If any queries or discussions you may make now.
Thank you very much, sir, for sharing your elaborate knowledge about welding robots' roles in industry. It's really enlightened our knowledge. Thank you so much, sir, being with us. Now this session is open for queries. Now participant can unmute yourself and you can ask your queries to respected speaker. It is humble request to all the participants kindly open your webcam. Respected speaker, sir, kindly open your webcam, sir. Dear participants, if you have any queries, kindly you can ask.
So, good morning, sir. Sir, am I audible?
Yeah. Please.
Yeah. Sir, nice lecture, sir. Thank you, sir. Thank you. You have started from the basics of robotics and ended with the application of artificial intelligence in optimizing the welding, etc. So, I would appreciate and maybe more thankful if you can show some video if available, or at least brief us regarding the latest state of art in the industrial scenario. It's like regarding welding.
Okay. Right. Okay. Actually, the video is not presented because I have not loaded that video. But I can show you the same concept once again to you, where our initial departmental students, they have done the welding operation. My screen is visible, right?
Yeah, screen is visible, sir. Yeah.
Right. Okay. So this is the robot that we are using in our automation lab. Okay. So this is also an industrial robot. Okay. So which has the 6 degrees of freedom and with the load carrying capacity of 6 kg. Okay. Which is equipped to the EcoFast laser sensor. This is okay. And moreover, as like the same structure like vision sensor, here we are also with one vision sensor. Okay, so this is NI based vision sensor. So these two sensors that we integrated to the robot. Okay, so this is the robot that has been used for welding operation, and this same technology we gave to Department of Atomic Engineering to perform the welding operation at their sources.
Okay.
Okay. And regarding some material, you can mail me. Then I can give you links of this. I mean, there's a few research articles that myself and my research scholar produced that I can share to you. Okay, sir.
Yeah, definitely, sir. Sir, can you please share your mail ID?
Right. Definitely, I will share at the end.
Yeah. Okay. Okay. Thank you, sir. Thank you.
Right.
Thank you very much.
Welcome.
Sir, does this laser welding, that sensor, laser sensor, cost like what you have shown in that image?
Yeah. The laser sensor cost is of 2.4 lakh rupees. Okay, and the robot cost is of 17 lakhs rupees.
Okay. Along with laser sensor, there was one more thing. What was that? Vision sensor. Yeah.
Vision
So
sensor. It is. Right.
is it
Please.
use, yeah, CCD camera or what? It is just.
It is CCD camera and one frame grabber. I mean to say a number of frames because the image acquisition should be in number of frames, right? So one frame grabber and its controller. I mean to say acquisition system.
So what is the total cost of that particular unit?
Particular unit cost is of for the particular unit. I mean to say that the NI Vision system cost is 4.5 lakh, I believe.
Okay, sir. Okay. Thank you, sir. Thank you. Thank you very much.
Dear participants, any other queries for discussion, I am available. Okay, and you can contact me through WhatsApp or email as per your convenient. Okay, just I am sharing my details here. Okay. Just I am. So you may kindly note for any other queries or discussions. I am always available with you. Okay.
Respected speaker, sir, kindly open your webcam, sir.
Yeah. Am I visible?
Yes, sir, you are visible.
Right. Thank you.
Thank you, sir. Thank you for your cooperation.
Right. Thanks for giving this opportunity once again, and thank you for the participants for your patience while listening my note, as well as again I am congratulating the participants as well as the organizing team of National Institute of Technology Pondicherry for conducting this faculty development course on future trends of robots. Thank you very much.